Welcome. In this video, we are going to discuss about the problem which was asked during the JFG Weekly 191. Okay, so let's get started. So let's go to first question. So first question here is you are positioned at 0, origin 0, 0, okay, on a 2D Cartesian plane, and the objective is to reach the target point x, y. In each move, you can travel either 2 units or 4 units. Okay, in one of the 4 cardinal directions, up, down, left, or right. The task is to determine whether the minimum number of moves needed to reach the target. Okay, let's see the examples. So first example, x equal to 2 and y equal to 6 is given. And for that the output is 3. Okay, so at first step, x goes from 0 to 2. Second step, y goes from 0 to 4. And then, so because of that, 3 steps are required to reach this position. Okay. And in next example, we can see that odd coordinates are given. So output is -1, which means we can't reach that position. So according to question, we can just move these 4 directions. We can't move diagonal. Okay, and we can travel either 2 units or 4 units. So the approach is simple. First, we are going to check whether the given coordinate is even or odd. If it is odd, we can just return -1. If it is even, we are going to divide the coordinate by 4, and the quotient will be the answer. Next, and then we are going, if it is perfectly divisible by 4, we can directly return the answer, or else then we are going to further divide by 2, which usually gives 1. So yeah, that's the approach. See, at beginning we are going to check even or odd, and then we are going to just divide by 4. Absolute function is taken because the coordinates can be negative as well. So that's the solution for first question. Coming to next question, that is longest palindromic array. So here an array is given. In one operation, you can replace any subarray with the sum of its elements. This transformation can be performed any number of times to transform array into a palindrome. So our task is to return length of the palindromic array. Okay. So let's see the example. So example 1, 2, 3 is given here. So according to the solution, this subarray 1, 2 can be added and converted to 3. Now 3, 3 becomes a palindrome. Okay, so the solution, we can use 2-pointer approach for this. So let's see how. So we are going to take another example and we are going to use 2-pointer. So we are going to take length, which is initially it is going to be 0. Length is going to be 0. And then we are going to take 2 pointers, left and right, and we are going to sum from left side as well as right side and compare them. And we have 3 operations. If left sum and right sum are equal, then we are going to increment length by 2. And then we are going to increment left pointer and decrement right pointer by -1. Okay. Now second case, if left sum is lesser than right sum, then we are going to increase left pointer. And in third case, if right sum is lesser than left sum, then we are going to decrement right pointer. Okay, so initially left will point towards 3, right will point towards 2. So now left sum, here it will become 3, right sum will become 2. And now you can see right sum is less than left sum, so we are going to decrement right. Right is going to be decremented and it will point towards 5. Now we are going to take right sum 5 plus 2, which is 7. And 7 is greater than 3. So we have to increment left pointer now. Now left pointer will be pointing towards 4. So now 3 plus 4 becomes 7 again. So 7 and 7 are equal. So now we are going to increment length. Length by 2. So now length becomes 2. And we are going to increase length to here and decrement right as well. Now left and right pointers are both pointing towards the same element. So we are going to exit out of the loop. And since they both are equal, we are going to add +1 to array, +1 to length. So at final, the length of the palindromic array becomes 3. So this is the solution which I was talking about. So taking left and right, and we are going to like check whether they are equal, whether it is left sum less than right sum, or third case. So these three cases we are going to check, and we are going to like find the answer to the longest palindromic array. And at last, if left and right are equal, we are going to increment the length by 1. So that's the solution. So that's it, and I hope you have learned something new here.